All right, continuing here in chapter 16, the next couple of types of problems are going to deal with binomial probability. To be binomial, we need to have two outcomes, usually referred to as a success and a failure. They have to be independent, so one trial cannot affect the other, and we need to have multiple trials. So in this situation, we have Kevin Love shooting 5 free throws in the next Timberwolves game. His free throw percentage is .82, assuming binomial probability. So there is a probability of him making it, .82, and missing it, which would be .18. They are independent because we're assuming binomial probability, and there's multiple trials, meaning he's shooting 5 of these. So when we do these, we're expanding a binomial looking at one specific term. So for number 10, his probability of making 5 out of 5, I would have .82, his probability of making it to the 5th power, .18 to the 0, and our combination would be combination 5. Choose either 0 or 5. Either one of those would work. In number 11, his probability of making 3 or 4. Again, we have a keyword of or, so we're going to add. And then his probability of making 3 would be .82 to the 3rd, .18 to the 2nd, making 3 and missing 2. His combination in front would be combination 5, choose 2, or 5, choose 3. His probability of making 4 would be .82 to the 4th power, .18 to the 1st, and combination 5, choose 1. And then we would add these together. Making at least 1, which means 1 or more. This would be 1 or 2 or 3 or 4 or 5. But it might be easier to look at just as probably making 0, which would be .82 to the 0, .18 to the 5th, 5, choose 5. And if this is the probability of making 0, making at least 1 is the complement of that. So I'm going to subtract all of this from 1. And I'll come back and do a few of these using the calculator, but I'm just setting these up. The calculator, you would just type them in exactly the way I have demonstrated these. Next problem is another example of binomial probability. Walks into a room with a pop quiz on trig identities. It's a 4-question multiple choice quiz. It has choices A, B, C, D, and E for each question. Use binomial probability to answer the following questions. So in this case, we've got a probability of getting a question right is 1/5. There's 5 choices. 1 of them is correct. And we are guessing on these. If I want to guess 4 correct, I would take this to the 4th power. I would have 4/5 to the 0 power, and my combination would be 4, choose 0. Exactly 3 correct would be 1/5 to the 3rd, 4/5 to the 2nd, or to the 1st, sorry, because there's 4 questions. And that combination would be 4, choose 1, or 4, choose 3. Either one of those would work again. Number 18, getting 2 or 3 correct, or again means we're going to add, and we're going to add the probability of getting 2 correct, which would be 1/5 to the 2nd, 4/5 to the 2nd, 2 right, 2 wrong, 4, choose 2. And then 3 correct would be 1/5 to the 3rd, 4/5 to the 1st, and 4, choose 1. And we would add those together. Just using the calculator now, I think if I would do something like this, I might put in or use the decimals. So 4 choose 1. 1/5 is 0.2 to the third. 4/5 is 0.8 to the first. So just entering that in to make sure you're doing this correctly. This would equal 0.0256. Let's move up here. And for example, let's do right here, getting 2 correct. If I enter this in, I'd have 5 combination 2 times 0.82 to the third power times 0.18 to the second power. And that individual probability would be about 0.1786. So just make sure that you can do those using your device or your calculator that you're using. Next type of problem we're going to do is combinations. So this would be if you're just choosing a group of something. So in this particular example, I have a collection of probability problems. I'm going to put them on an 8-question FST test. And I have different types of problems. So in this situation, I'm basically choosing 8 of the 20 questions. So that will be my denominator. Now, the numerator is what I'm looking for. So in number 13, the probability that all 8 are easy means I need to select 8 of the 13 easy questions. And then I would just divide those. Number 14, that the test will have 5 easy, 2 difficult, and keyword and 1 impossible selected problem. Once again, I am choosing combination 8 choose 20. And then I would have 5 choose 1. Or we have 5 easy, so I'm going to have 13 choose 5. My mistake. I have 2 difficult, 5 choose 2, and 1 impossible. There's 2 impossible, I'm choosing 1. And I would multiply those together because it's the and. Number 15, what's the probability the test will have no impossible? If I'm not going to have any impossible, that means I'm having all either easy or difficult, and there are 18 of those. So of those 18, I'm choosing all 8, divided by, again, our familiar denominator of 20 choose 8. What's probably the test will have 4 difficult and 4 impossible. So again, 20 choose 8. 4 difficult would be 5 choose 4. 5 difficult choosing 4. Impossible, there are 2 of them. Is there a way I can pick 4? No, there's not. That can't be done. This is impossible. My probability would be 0. Next type of problem, we're heading to a casino to play bingo. There are 15 V-balls, 15 eyeballs, and so on in the hopper. 75 total. I'm choosing 4. So here my denominator will be 75 choose 4. For number 12, I want all 4 to be eyeballs. So of the 15 eyeballs, I'm going to pick 4 of those. Everything else would be choose 0. So that would be enough to do the problem. 13 as above, we have at least 1, which remember is usually done using the complement. So we're going to think about not having any eyeballs at all. That would mean I'm choosing 4 either B's, N's, G's, or O's. There are 60 of those, and I'm going to pick 4 of those. So this would be the probability of no eyeballs whatsoever. The complement, 1 minus that, would be at least 1. What's probably that 3 b-balls and 1 eyeball are drawn? So again, 75, choose 4. I need, of the 15 b's, I'm going to choose 3. Of the 15 i's, I'm going to choose 1. It's and, so I'm going to multiply those. Let's probably get 1 I, 1 N, 1 G, and 1 O. 75, choose 4 would be my denominator. 1 eyeball would be 15, choose 1. 1 N would be 15, choose 1. 1 G would be 15, choose 1. And 1 O ball would be 15, choose 1. Once again, just showing you some of the answers here using combinations. That number 12, which is 15 combination 4, and I'm dividing by 75, choose 4, comes out to be 0.001123. Very unlikely that you'd get all eyeballs chosen from that. Okay, number 14, making sure you do that correctly on your calculator. Be 15 combination 3 times 15 combination 1, and then I'm dividing that total answer by 75 combination 4. And this would have probably a 0.0056. Once again, not very likely to happen. And the last part, these last 2 questions, dealing with conditional probability and tree diagrams, I will create a new video for this.